4.
Good afternoon, everyone, and welcome to the 54th Lunar and Planetary Conference. This is the second press conference of the week, and the panelists will be speaking on New Horizons, the distant discoveries in the outer solar system. We are delighted to have all of you here, and those of you in person and also those online. My name is Soraya Faruqi, and I'm the Director of Communications at University Space Research Association, which is sponsoring this press conference. And I'm assisted by Julie, who's the Communications Manager at LPI, and my other colleague, Mike Buckley, who is the Senior Communications Manager at APL. So just a couple of housekeeping items. Just wanted to let you know that the questions online will be monitored by Julie, and she will then direct it to the various panelists. And that will be holding true for all conferences. And with that, Mike, I'm going to turn the podium over to you so that you can then go ahead and introduce the speakers. Thank you.
All right, thank you. This is exciting. Say that after more than 5 billion miles and 17 years into a mission that included the first close-up exploration of Pluto and the first encounter with a planetary building block in the Kuiper Belt, NASA's New Horizons continues to shed light on these mysterious worlds in the outer solar system. Today we have members of the New Horizons team to discuss the discoveries that are still happening from the data gathered during the Pluto flyby in 2015 and the flight past Kuiper Belt object Arrokoth in 2019. I'll point out that the materials that they're going to present today are going to be available on the New Horizons website, and that's pluto.jhuapl.edu. And we'll also have a summary of the press conference on shortly afterward. So here to bring us up to speed on the discoveries from New Horizons are Becky McCauley-Wrench, the program scientist from NASA headquarters, Alan Stern, the New Horizons principal investigator from Southwest Research Institute, Oliver White, a New Horizons co-investigator from the SETI Institute, Ishan Mishra, a postdoctoral researcher from NASA's Jet Propulsion Laboratory, and Will Grundy, a New Horizons co-investigator from Lowell Observatory. Each of them will have their discussion points of discoveries from Pluto and Arrokoth and a look ahead on what's to come from some observations from New Horizons. We'll start with Becky.
Okay, great. Thank you so much. So I just want to say this is an amazing mission. New Horizons has always amazed me because here we are flying by Pluto less than 100 years after we first discovered it. And then the same with Arrokoth, where we didn't even know it existed whenever we first launched. And then we got to fly by that as well. And so those are just amazing things that we've been able to accomplish over these past 17 years since launch. And today, what we're here to do is to shed more light on those objects that we've learned so much about. They're no longer just points in the sky. They are things that we have learned more about as planets and bodies out there in the outer solar system. And this is data that, is from 7 years ago, but it is still giving us new discoveries. And so we're just really excited about that. And we're also really excited about where New Horizons is today, out at its unique location in the outer solar system, and what it's going to help us learn about the ice giants and other bodies. And so with that, I'll go ahead and pass it to the New Horizons science team.
Well, thank you, Becky, and welcome this afternoon, everybody. We're going to be presenting 4 different results in the next few minutes on 4 very different topics of science for New Horizons. I'm going to kick it off and talk about new results from the flyby of Arrokoth in 2019, the first Kuiper Belt object ever explored by spacecraft. And then the gentleman to my right, starting with Oliver White and then Ishan Mishra, are going to talk about some new discoveries on the planet Pluto from New Horizons data. And then Will Grundy on the far right will be speaking about something new that New Horizons is going to be doing. One of many things we're going to be doing in this next extended mission, which is looking at Uranus and Neptune in ways that we can't from the Earth or any other spacecraft, to shed new light, not just on those 2 important planets, but also exoplanets like Uranus and Neptune across the galaxy. So with no further ado, let me tell you about the Arrokoth story, because it's very exciting. And it's really telling us something very important about the origin of our solar system. So as background, after the flyby of Pluto, we redirected the New Horizons spacecraft to a target discovered space telescope, now called Arrokoth, which is the Powhatan Indian word for sky. And you can see on the left side here the trajectory of the craft from Pluto, actually from the inner solar system to Pluto and outward past Arrokoth and its flyby. And then you see on the right the actual object, Arrokoth, in true color. You see a scale bar next to it. It's about 21 miles or 33 kilometers in extent. And because this object is orbiting so far from the sun, it's always been in a deep freeze. The ultraviolet radiation out there is much lower than in the inner solar system, and so are the collisional rates. And so, like its brethren across the Kuiper Belt, Arrokoth is very primitive, very unevolved in that deep freeze over all these billions of years. In fact, Arrokoth is the most primitive body ever explored by spacecraft. It's also a contact binary. You can see that just by looking at it. There are two lobes that are stuck together at that seam or neck, as we call it. And from the geology, we can see that that the formation process involved a very gentle merger of these two lobes. It's a very important clue to how Arrokoth and other bodies out there, these so-called planetesimals or planetary building blocks, were formed. And these are the objects that led to the formation of Pluto and other small planets out in the Kuiper Belt. So what our study that we're reporting here at the Lunar and Planetary Science Conference is about is that we've been studying these enigmatic structures on Arrokoth, primarily on the larger of the two lobes. We call them Arrokoth's large mounds. And in this geological map, you can see the individual mounds. They look like Lego pieces on the large lobe. And what we found is by studying them in comparative ways, their colors, their compositions, their reflectivities, their sizes, and other structural properties, we found that they're extremely self-similar, that the individual lobes have similar properties in all of these respects, which is a clue to their origin, and which we believe is telling us something very important about the formation of Arrokoth, and it's this, namely that as the cloud of material that came to make Arrokoth was collapsing, shown in the left-hand frame of the three frames on the left, that cloud apparently produced like-sized objects, those mounds, which then came together to form the larger lobe. And probably something like that happened on the smaller lobe as well, but it's harder to tell because there's a very large crater called Sky, which has obliterated a lot of the original surface geology in being formed. So as you see in the three images on the left in this slide, Arrokoth's natal cloud collapse took place, and then that formed the two lobes, and the two lobes then entered orbit around one another and tidally interacted. And as they lost angular momentum and orbital energy by ejecting some of the remaining material in the natal cloud, they merged together or almost docked at something like walking speed. And as I said, all the geological evidence points to that scenario. We published that scenario in 2019 and 2020, both in the journal Science. But the news here is about the properties of these subunits that we see, the so-called mounds that are so self-similar. And so now I'm going to click on the animation on the right, which shows you kind of a cartoon view of what we think modeling will soon bear out, which is this concept that the individual mounds originally were orbiting in the natal cloud and came to form the larger lobe of Arrokoth this way. This is a very important clue to how these planetesimals form across the outer solar system, maybe even in the inner solar system. We know that there's a lot of work ahead in terms of computer modeling to understand why this self-similarity should take place. But the discovery seems pregnant with a lot of possibility, and we're really looking forward to the next steps in this work, leading now from the data to the modeling. Thank you very much, Oliver.
Thank you very much, Alan. So the topic of my presentation is true polar wander on Pluto, which in the almost 8 years since New Horizons flew by Pluto is still very much an ongoing, an active subject of active research and debate amongst Pluto scientists, and which we've come to realize is very important phenomenon for understanding Pluto's very early geologic history. So what is true polar wander? True polar wander is when a planet or moon rotates with respect to its spin axis, which is caused by redistribution of mass within the planet or moon. In other words, the locations of the north and south poles change on the body, and sort of these two animations sort of show how it works, and these exaggerated examples on Earth on the left. If you were to accumulate an enormous bulge in Western North America, you would get what we call a positive mass anomaly. In this case, the bulge would reorient the planet such that it gets closer to the equator. But if instead you were to gouge out an enormous pit in Western North America, you would kind of have a negative mass anomaly. And in this case, that basin would move the planet such that the basin is closer to the pole. Now, we know that true polar wander has affected quite a few planets and moons in the solar system, but one planet that it's been most unambiguously affected, we think, is Pluto. And how do we know that it's affected Pluto? It's the key is the Sputnik Planitia. At the top left, you can see Sputnik Planitia is this bright sort of enormous deposit of nitrogen ice on the surface that we can see is filling a giant impact basin. You can see in the topographic map at the top center there. And we realized fairly soon after the New Horizons flyby that Sputnik Planitia is oriented. It's located pretty much very close to the Pluto-Charon tidal axis. Pluto and Charon are a binary planetary system. They always have the same face pointed towards each other. And in such a system, if you have a positive mass anomaly on the surface, then it will move not just to the equator, but towards that axis. And so if that means that Sputnik Planitia is a positive mass anomaly, how do you get that from a basin? The answer is what's filling it and what's underneath it. It's filled with nitrogen ice, which is denser than the water ice crust. And you also have the denser subsurface ocean, liquid water ocean that upwarps in response to the creation of the basin. So this is what we know about true polar wander on Pluto. We know that it happened, we know the mechanism by which it happened, and we also know that it must have been a very profound event in Pluto's early geological history. Pluto essentially flipped on its side. The locations of the rotation axes moved hundreds, if not thousands of miles, sort of, if you imagine like San Francisco sort of moving to New York on Earth. It's, yeah, an extremely important event, but there is a lot we still don't know about true polar wander on Pluto. For instance, we're not entirely sure exactly how Pluto was oriented before true polar wander, and this has been the subject of some modeling efforts by New Horizons team members since the flyby. In particular, the degree to which true polar wander occurred depends on how big the mass anomaly was. In this image on the right, you can see some modeling results here where original locations of Sputnik Planitia on the surface are mapped out depending on how big the mass anomaly is, like how much nitrogen ice there was, how much uplift of the subsurface ocean there was. But one thing that, in addition to this modeling, these modeling efforts, one way in which we've recently realized we can perhaps approach the question of true polar wander on Pluto is looking for evidence in Pluto's very ancient geology for how Pluto may have been oriented before true polar wander. One example of one of these geologic features is Pluto's ridge trough system. You can see in the topographic map at the left. It's this enormous, very ancient tectonic system consisting of these parallel mountain ranges and deep valleys that extends across the whole of the near side of Pluto that New Horizons saw up close. It's a very enigmatic feature. It's aligned along a great circle. That is, it looks as though it might extend around Pluto's whole circumference. It's a very rare feature that you see in the solar system, but it's been suggested this might be a paleo equator on Pluto. This might have been aligned along the original equator before true polar wander occurred. And if so, it might help explain some of the ancient landscapes we see on Pluto. At the top left and the top right, we see these ancient glacial landscapes, these valleys we think were carved by nitrogen ice. We can't really explain that in Pluto's current configuration. The climate doesn't really work. It's too seasonally extreme in the poles to get long-term survival of nitrogen ice there, unlike at the equator, where the much more mild climate sort of allows nitrogen glaciers to exist like we see today. But if the ridge trough system was a paleo equator, then perhaps the mild climate before true polar wander would have allowed nitrogen ice glaciation to occur in this what is now the polar zone. So there are ongoing efforts to search for more ancient landscapes. I'm finishing up a geologic map of Pluto at the moment that may help us to identify some of them and help sort of more constrain how true polar wander occurred on Pluto. And now I'll hand over to Ishan.
Thanks, Olu. Hi, I'll be talking about some new evidence for the extent of these fascinating landforms called bladed terrain that exist on Pluto. So near the eastern limb of the encounter hemisphere of Pluto, New Horizons found a very interesting landform called the bladed terrain. And on the top right figure, there's a zoomed in image of these sort of subparallel sets of steep ridges. And you see that there's a predominant north-south orientation. And this is very reminiscent of penitentes on Earth, which are shown in the bottom right figure in that Atacama Desert in Chile, which are these landforms that are formed from sublimation of water ice deposits. And on Earth, they are about a few meters tall, but on Pluto, these are hundreds of meters tall and formed from methane ice deposits. So Oliver in his presentation talked about ancient geology, but bladed terrain are recent landforms that show active response of Pluto's surface to its changing climate. So in this figure, I'm showing a topographic map of Pluto on, at the top. And you see that the region where the bladed terrains are found, that is denoted by the dotted white circle, are high altitude regions where we also find a lot of methane, which is shown in the bottom map. So, so that is why we think that in high altitude regions of Pluto, methane ice is condensing out, forming deposits, which is slowly getting sublimated away, forming these ridge-like bladed terrain landforms. What's interesting, though, is that as you can see in the bottom methane map, the methane absorption extends out to the far side of Pluto. That was not very well imaged by camera, but this points to the it points to the possibility of these bladed terrain regions extending way beyond the eastern limb of the encounter hemisphere into the far side of Pluto. And so the work I'm presenting here is a new line of evidence for the presence of these bladed terrain-like landforms in the far side of Pluto via looking at the reflectance behavior of these landforms. So to peer below the resolution limit of a camera, one way that we can use, one method we can use to learn about the physical properties of a planetary surface is by looking at its photometric behavior, which is to say how the reflected light of that surface changes as your observation geometry changes. So New Horizons flew by Pluto, and it was in this perfect position to view the same parts of its surface at varying vantage points. And that resulted in us getting reflectance profiles at a varying observation angles, such as the plot I'm showing on the right side in the slide. And so what I'm comparing here is the reflectance profile of the bladed terrain that we saw on the encounter hemisphere in orange with the presumed or putative bladed terrain that we infer from the methane absorption features in the far side of Pluto. And the physical property that we're interested in here to infer from these reflectance curve is the surface roughness. So whether the surface is smooth like a desert versus whether it's rough, such as what you would expect with from a surface covered in bladed terrain like features. And so what we're finding here is that both the bladed terrain on the encounter hemisphere and the presumed bladed terrain on the non-encounter hemisphere are very rough, and they're rougher than the average roughness of Pluto, which further points to their similarity. And what's remarkable is that while we were lucky to find these bladed terrain deposits on just at the eastern limb of our encounter hemisphere, it seems like bladed terrain might be one of the most common landforms on Pluto. And so, as Alan put it, this might be of the bladed terrain planet. Thank you. I'll pass it now to Will.
Thanks, Ishan. Can you? All right, so I'm going to change gears a little bit here and look ahead to what some of New Horizons has planned for the near future. We've got a lot of interesting observations coming up soon, starting in August, and they extend into astrophysics and heliophysics as well as planetary science. I'm going to tell you about planetary science observations, specifically to look at the ice giant planets. And the ice giants are giant planets just like Jupiter and Saturn, but unlike Jupiter and Saturn, they have abundant heavier elements, not just dominated by hydrogen and helium. And these are a high priority for future spacecraft exploration. And they're also representative of a class of planets that's ubiquitous throughout the galaxy. So let's get to know them. Jumping ahead to the next slide, this is what New Horizons is going to do, is take color pictures. And these are not, stunning images like you get when you're right up close. These are sort of pale blue dot looking images. But what's special about them is indicated by the wire mesh diagrams that indicate the geometry to the right of each image. And what's key there is that from the point of view of New Horizons, the planets are lit from off to the side. And what that means is that the light that's scattered back in the direction of the sun and the earth is not the light that's coming to the spacecraft. We're seeing light scattered in a direction that you could not possibly see from Earth or the inner solar system. And so that's a unique vantage point that New Horizons is exploiting to learn more about the planets. And the other thing that's worth noting is that we will not just collect single images like these test images from 2019 that are shown here. We're going to take pictures as the planets rotate so that we can see their evolving cloud structures coming onto the part that's lit and that we can see, and rotating out as the atmosphere evolves. Now, a future observation of an exoplanet around another star is going to be this same sort of side lit geometry typically, because if it's lined up with the star blinds you. So we're going to be looking at planets that are off to the side of the star, and it's just going to be a dot. So what can we learn from a dot? Well, we have the advantage here that we know a lot about Uranus and Neptune because we've studied them for decades and decades, and we flew the Voyager spacecraft past them in the 1980s, and there's going to be more space missions to come. And so one thing that we're doing in these upcoming observations is to work with the Hubble Space Telescope, and there's a program to monitor these planets led by Amy Simon at Goddard, and we're coordinating very closely to try to get the observations as close to simultaneous as we can make them. And the advantage of this is that what Hubble will see is what the cloud patterns are doing that day, and at the same time as New Horizons is seeing them vary as they rotate, and we can work both ways. We can learn more about Uranus and Neptune because we've got the light that's being scattered away from Earth, and also the light that's scattered back towards the Earth, which Hubble is going to look at. And that enables us to understand better the energy balance in terms of how much sunlight is being absorbed versus scattered into the various directions, and how the cloud processes and convection in the atmosphere are influencing that, and how the energy balance plays out. The other thing is that if we were to try to interpret those blue dot observations like we were looking at an exoplanet, we have the answers in the back of the book from Hubble and what we've learned from other studies. And so we can get some more confidence in our ability to interpret these kinds of observations, which are going to be very exciting when they do come along. And with that, I think we could.
All right, pass that back. So we'll now leave it open for questions. If we have any in the room, scan that first. And if not, we'll go to online. All right, let's see what the online crowd has to ask.
Okay, virtual participants can use the raise hand feature to ask a question. You will be prompted to unmute yourself. Please state your name and affiliation first, followed by your question. Okay, we have our first question.
Hi, this is Alan Boyle with GeekWire, and I was hoping to hear maybe a little bit from Alan or somebody else about the future plan for New Horizons observations. What are the coming attractions?
Yeah, thank you for that question, Alan. We have a wide variety of observations that New Horizons is going to be undertaking in this second extended mission. Will describe the Uranus and Neptune observations, which are really unique and can only be done by a spacecraft that's far beyond Uranus and Neptune. And likewise, all of the science that we're doing in this extended mission is similar in that we've limited the science to things that you can't do from the Earth or Earth orbit or the inner solar system. That's the study of Kuiper Belt objects that we pass by in the distance, the search for a flyby target to make a second close flyby of a Kuiper Belt object, the study of dwarf planets in the distance, that unique geometries that you can't see from the Earth, the study of dust produced by collisions between Kuiper Belt objects that traces out that collisional history as a function of distance from the sun. Then in heliospheric science, we're studying the outer heliosphere. This is the sun's cocoon of influence before we get out into the interstellar medium where the Voyagers are. And no spacecraft except the Voyagers and the Pioneers have ever been this way, but New Horizons carries capabilities that those much older spacecraft either didn't have the technology for or simply didn't have the instrumentation for. So we're able to study the pickup ions, which the Voyagers and Pioneers were not. We're able to study the dust distribution in the heliosphere. We're able to do some other things that just couldn't be done. And we're traversing the outer heliosphere at a different phase in the solar cycle. So that'll make some nice comparisons with the Voyager data from back in the 90s and 2000s when they passed through the same region. And then finally, in astrophysics, we're taking advantage of the fact that we're far beyond the dust scattering from the so-called zodiacal light in the inner and middle solar system to actually probe the cosmic optical and ultraviolet backgrounds in ways that you can't, because that dust scattering in the inner solar system is like a fog that prevents you from seeing the very faintest emissions from the universe. And so we're going to be doing maps of the entire sky in the ultraviolet, and we're going to be looking at selected regions in the optical to try to understand those two background signals, which are already telling us from precursor observations that there's at least one source of unknown light coming from extragalactic space or cosmologically. And then finally, we're going to be also mapping the local interstellar medium in hydrogen light to understand the cloud structures and other structures that have never been mapped before beyond the fog of the hydrogen in the inner solar system, where we can see that more clearly. And we'll do that not just once, but a number of times so that we can actually look for changes as a function of time and the parallax that our spacecraft's travel through the solar system allows. Altogether, about a dozen different observations, different kinds of observations made to benefit astrophysics, heliophysics, and planetary science.
And can I add to that? Just to speak beyond the extended mission, the Planetary Science Division and the Heliophysics Science Division are coordinating on the future of New Horizons mission. As part of that, Heliophysics plans to put out an RFI in the near future to understand the potential for the science to be achieved in the future as well.
Are there any other virtual questions? So we have one more. Another one. Please state
Hi.
your name and affiliation.
Yeah. Greg Redfern, WTOP Radio, and thank you for this great conference to update New Horizons. And I'll put this question to Alan Stern. Alan, is there any plans to coordinate observations between New Horizons and James Webb Space Telescope regarding Pluto or any of the Uranus Neptune observations you described? And thank you very much, and go New Horizons.
Well, thank you very much. We are not directly collaborating with the JWST project and observatory in terms of joint observations. There are JWST programs to study Kuiper Belt objects, I believe to study Arrokoth in new ways, and also to study Pluto. And we're very happy with that because the data fusion between what New Horizons generated and what James Webb can generate are going to lead to new knowledge. But we are collaborating with the Hubble Space Telescope. We'll describe some of that. We're also collaborating with Voyager, which is already out in interstellar space. And those two science teams, ours and the Voyager team, are working closely together. And we're doing some unique observations we call point-to-point tomography of the hydrogen distribution within the solar system, in which New Horizons, the ultraviolet spectrometer onboard New Horizons, is used nearly simultaneously with ultraviolet spectrometers scattered around on other spacecraft orbiting the moon, orbiting Mars, on their way to Jupiter, and even in Earth orbit, in order to make line of sight observations between those pairs of spacecraft to study the three-dimensional distribution of hydrogen. So there's a lot of collaboration between different NASA missions, and possibly even in the future with international missions, but no direct collaboration at this point with James Webb.
Thank you.
Okay, are there any other questions from our virtual audience?
Okay, finish there. We'll do one more sweep of the room. Any questions here? One in the back.
Yeah. Sorry, my name is Alvin. I'm from JPL. So my question to Dr. Oliver White. Probably I missed your first part of your presentation. So the geological map you showed and your preparing shows, or the previous study shows, there are some cryovolcanic evidence in the southern hemisphere of Pluto, and also there are some fault and also the cryovolcanic evidence on the western part of Sputnik Peninsula. Does your geologic map also support having cryovolcanic evidence, for instance, caldera complex or supervolcanic band on the eastern part of the Sputnik Peninsula as well? It might be a research question and one-to-one question, but I'm sorry for asking that.
Yes, not really cryovolcanism as such. I mean, that we do notice that the east of Sputnik Peninsula, there are a lot of deep pit complexes. Some have, like Alan Howard, sort of one of New Horizons team members suggested might have a cryovolcanic thing to them, but it's difficult to say. There aren't really any sort of obvious deposits, and it's possible a lot of the pits are quite sort of aligned. There's definitely a tectonic structural element to them, but it's hard to identify any actual sort of deposits derived, sort of that may have been erupted from those. So yes, nothing as provocative as Wright and Picard Montes to the south of Sputnik, certainly. So yes, I'm not probably not going to interpret it in my map as anything specifically cryovolcanic there.
All right. So I think I haven't gone around with the opportunity for questions. I'd like to thank the panelists again for all that information and for bringing us up to speed on New Horizons, on the mission that continues to explore. Another reminder that the graphics from this briefing will be posted on the mission website. That's pluto.jhuapl.edu. We'll also have a recording of this briefing posted there shortly. And would say too that join us again tomorrow for 2 press conferences from LPSC on discoveries of the moon and on Venus. So again, thank you for joining us. Thank you, team, and we'll see you then.